Alright guys, so today we're going to go ahead into section 4.2, and I have waited for that bell at lunch, so I'm sure it's going to ring any second now since I've been waiting forever and it hasn't rung. Alright, so today we're going to look at the unit circle and trig functions. So again, we're heading back a little bit into geometry, so hopefully you haven't forgotten too much of that. So first I want to tell you that the unit circle is defined as x squared plus y squared equals 1. So the unit circle has a radius of 1. Okay? Now we're going to go ahead and define our trig functions. So in an ordered pair, we normally have x, y. So the x value is going to represent the cosine, and the y value will represent the sine of the function. Okay, so we're going to go ahead and write that out. The sine function, which we abbreviate sin, is equal to the y coordinate. The cosine, which we abbreviate cos, is the x coordinate. And if you remember back from geometry, tangent, which we abbreviate tan, is defined as sine over cosine. So in our world, it would be y over x. Now, these functions all have inverse functions. So the sine's inverse is called a cosecant. Now, this is a new word to you, so we didn't talk about these functions in geometry. Since it's an inverse function, or I'm sorry, not an inverse, a reciprocal function. I keep saying it wrong. It is a reciprocal function. So it is 1 over y, but y cannot equal 0, because again, if y is 0, we get undefined. Right? The reciprocal function of cosine is called secant, and it is 1 over x. Again, x cannot equal 0. And then the reciprocal function of tangent is called cotangent. These have abbreviations as well. I should have been giving them to you. So the reciprocal function, if the original function is y over x, the reciprocal function is x over y. Again, y cannot equal 0. Let me go ahead and write their abbreviations in here. So cosecant is CSC, secant is SEC, and cotangent is COT. Okay, so those are their abbreviations. So, how are we going to use this newfound information? So, in example 1, use each figure to find the values of the trig functions at t. So, use the figure to find the values of the trig function at t. Okay, so it's got my unit circle. That's not drawn perfectly, but it'll work. And t is at the square root of 3 over 2, negative 1/2. That's a little teeny tiny t. Let me zoom in on him a little bit. Okay? Alright, so that's a little t. So I want the sine of t, cosine of t, tangent of t, cosecant of t, secant of t, cotangent of t. And you can't see half of what I wrote, so let me unzoom. Alright? Here we go. We know that the sine function represents the y value. So the sine of t is negative 1/2. Now, what do we know about the cosecant? We know the cosecant is the reciprocal function. So what's the reciprocal of negative 1/2? Flip it upside down, you get negative 2. Cotangent represents the x value. So what's the x value? Square root of 3 over 2. So the reciprocal of that would be 2 over the square root of 3. But do you remember from Algebra 2 that you cannot leave a radical in the denominator? So I'm going to go ahead and clean this up by multiplying both by a square root of 3. Because what that will do is in the numerator I get 2 square roots of 3. In the denominator I get the square root of 9. 3 times 3 is 9. And now can I just clean this up and get 2 square roots of 3 over 3. Alright, tangent's going to be a little bit tricky. Tangent, if you remember, was defined as y over x. So I know that y is negative 1/2 divided by square root of 3 over 2. Now, this is called a compound fraction or a complex fraction. So what we're going to need to do is to try to clean it up. So I'm going to multiply by his reciprocal because that will clear this extra denominator I've got going on. And whatever I do to the bottom, I do to the top. So these all go away, and I'm left with negative 2 over 2 square roots of 3. And if you don't mind, I'm going to scribble this out just for a minute so we have some room to work. Do you agree now that I can simplify this to negative 1 over the square root of 3? Because 2 divides into 2 one time. But can I leave that square root in the denominator? Nope. So I'm going to multiply by the square root of 3. And I get negative square root of 3 over 3. So now if I want the cotangent, and I'm just going to go ahead and put it on this next piece of paper. I obviously didn't give myself enough room. That is cosine divided by sine, or x divided by y. So my cosine was the square root of 3 over 2. My sine was negative 1/2. Again, I have a complex fraction. So I'm going to go ahead and multiply by the reciprocal of the denominator. So negative 2 over 1, negative 2 over 1. These all clear out. Up here, do you agree that you can cross-cancel your 2's and you get negative square root of 3? Because those go away. Alright, let's try one more. Not quite so complex. Alright, so number 2, we have our unit circle again. This time, t is over here at pi. So I want you to think for just a second. If this is a unit circle, do you agree that this point would be 1, 0. And this point would be 0, 1. And where pi is would really be negative 1, 0. And down here, this point would be 0, negative 1. So that's how our unit circle plays out. Now, I can ask you for the sine of t, or the sine of pi in this case, the cosine of pi, the tangent of pi, cotangent pi, secant pi, cosecant pi. Alright, let's think. Sine represents which value in your ordered pair? Cosine, sine, right? X comes before Y, C comes before S. So my sine would be 0. My cosine is -1. What's the reciprocal of 0? Well, do you agree that there's a 1 underneath here? So the reciprocal 1 divided by 0, but can you divide by 0? No, so it's undefined. Now, underneath this -1 is a 1, if you want to think of it that way. So the secant would be his reciprocal, which is still -1. Tangent is sine over cosine. So it would be 0 divided by -1, which is 0 divided by -1 is 0. The cotangent is the reciprocal of the tangent. -1 over 0, which is undefined. Okay, so I want to go ahead and take you back and explain to you where some of this stuff is coming from, but then I'm going to give you a super easy way to remember this stuff, okay? But I at least want you to have a foundation of where this information is coming from. So I want to take you all the way back to geometry when you dealt with 30, 60, 90-degree triangles. So these were those special right triangles that teachers talked to you about, and they made you learn a little pattern. So the little pattern was, across from the 30 was, depending on who you had, I'm going to say it's 1. Across from the 90 is 2. Across from the 60 is the square root of 3. You might have had teachers, in fact, when you had me for geometry, if you had me for geometry, I would have taught it as A, 2A, A square roots of 3. But for right now, I need you to, let's pretend that A was 1, okay? And I want to look at this triangle. So focusing just on this triangle. Let's go back and do some old school geometry. If I want the sine of 30, do you agree that it was SOHCAHTOA? Or however you memorized it when you were in geometry. So sine is O and H. So from the 30, do you agree that the 1 is opposite you? Your hypotenuse is always across from the right angle, and that means this is adjacent. So the sine of 30 would be O over H, which is 1/2. Let's do the cosine of 30. So cosine is A over H. So what is adjacent to the 30? Square root of 3 over the hypotenuse 2. And then the tangent of 30, tangent is O over A. So O over A would be 1 over the square root of 3, but you can't leave a radical in your denominator, so you simplify him, and you get the square root of 3 over 3. Okay? So that's where the trig functions for the 30. 30 is going to be a really special angle for us. Now I want to look at the 45, 45, 90 triangle. 1, 1, square root of 2. Or, if you had me, it was A square roots of 2. But I need the A's to become 1 now, because we're dealing with a unit circle. Alright, let's go through it again. The sine of 45. Sine is O, so let me go ahead and label. Opposite me is 1. My hypotenuse is the square root of 2. And that means this is adjacent. The adjacent side is just whatever's left over. Alright, so sine is O over H, so it'd be 1 over the square root of 2, but I can't leave that like that in the denominator, so I clean it up, and I get square root of 2 over 2. The cosine of 45 is A over H, so again, it's 1 over the square root of 2, which we already know is square root of 2 over 2. And finally, the tangent of 45 is O over A, which would be 1 over 1, or 1. So that's the next special angle. It's called a 45-degree angle. The last one I want to focus on is the 60 degree. So we're going to go back to that 30, 60, 90 triangle. Ha! I knew there'd be a bell. Obviously, there'll be another one in just a minute. Alright, so head me back to the 30, 60, 90, and I apologize, I tried to do these videos after school, but this one and the next one had to be done at lunch. Alright, so we know that it's 1, 2, square root of 3. So, see if you can tell me what the sine of 60 is. So go to your 60-degree angle. Who is directly opposite you? The square root of 3. Who is your hypotenuse? The 2, which means 1 by what's left over is the adjacent. Okay, so sine is O over H. So square root of 3 over 2. Cosine of 60 again, if you need to write this down so you can remember what's what, cosine is A and H. So A and H is 1/2. And then the tangent of 60, tangent is O over A. So O over A, sorry, square root of 3. Okay? Now, another thing that I need to tell you guys is this saying: all students take calculus. And that's going to help us, whoops, except I, for the life of me, cannot spell, C-U-L-A-S, there we go. That's going to help you figure out what is what sign in each particular quadrant. Okay? So, it goes all, and remember we normally go counterclockwise, right? When you labeled your quadrants at 1, 2, 3, 4. So it's all students take calculus. What that means is that all the trig functions are positive. And this stands for the sine is positive. T would stand for tangent is positive. And C stands for cosine is positive. Okay? So, tomorrow we will begin by putting all that information you just derived into a very usable function. And I'll show you how to do that. I do want to go ahead and just, because I have just a couple seconds left, I want to talk about some basic trig identities. You already know that the tangent of t is defined as the sine of t over the cosine of t. You also know that the cotangent of t is cosine t over sine t. We've already talked about those. The other ones that I want to talk to you about real quick are called Pythagorean identities. We'll use these a lot in the next chapter, but we're going to go ahead and at least talk about them a little bit now. So there are 3 of them, and this is where we'll end. I have sine squared t plus cosine squared t equals 1. The next one is 1 plus the tangent squared equals the secant squared of t. And the last one is 1 plus the cotangent squared t equals cosecant squared t. This is the one that I expect you to memorize. The other guys, we will use them as we need them. Alright? So tomorrow I'll teach you how to pull all this stuff together and we'll go from there. You guys have a great evening.